Hi, I'm Ed Amoroso from Tag Cyber, and I'm here with my friend Ted Shorter, who is the CTO and co-founder of Keyfactor. Ted, how you doing?
I'm doing great, doing great. Glad to
That's
be
so
on.
nice. Nice that you could make some time. I'm sure people are watching want to hear all about the work you're doing. Hey, first, why don't you tell us a little bit about Keyfactor? That's a good way to get started, and then we'll dig into the technology.
Sure. Keyfactor is focused on managing digital certificates and cryptographic keys, both in the enterprise and in IoT kinds of applications. So we have a highly scalable software platform that some of our customers can choose to license and use it on their own stuff. We can also run that for customers in the cloud in a Keyfactor hosted fashion, along with dedicated purpose-built PKI that we run for a large and growing number of large enterprise organizations. And we also do a lot of really interesting things with certificates and keys in the IoT space, vehicles, airplanes, medical devices, and things along those lines.
That's interesting. PKI, public key technology, so traditional and been with us for so long, and yet it always feels like it's sort of fresh because there's so many new applications. Now, one of the things I know you guys do, which I think is awesome, is this PKI as a service.
Right.
And I guess it's just inevitable that we, as a service, the PKI again, it can only help. Talk a little bit about that. What's been your experience in providing this type of technology to business clients as a service?
Yeah, we actually started doing that about 8 years ago or so, right around the same time that we launched the software platform. And really both of those came out of the unmet needs that we saw in our customer base. The PKI as a service really comes from the fact that a lot of organizations struggle with getting and keeping the expertise in-house to run PKI, right? You can buy certificates from the public providers, the certs that need to be trusted by every browser and so forth. Most organizations also need privately rooted PKI for things like Wi-Fi and VPN and internal devices, web services, and the list of those sorts of applications is exploding on a daily basis. But keeping well-run, well-architected, secure, scalable PKI running is not something that it's not a set and forget technology. It's not something you just buy and stick in a rack and let it run. It's not something that you can just hit next 5 times and have it serve the needs of the enterprise on an ongoing basis. It requires deep expertise at design time, and then every once in a while throughout the lifespan of the PKI, which in most cases is very long, 10 to 20 years. And so we really created the offering out of the need that we saw of just keeping those folks with those skills in-house. There was a lot of cases where we saw well-run PKI at a customer or two, and then they would get promoted or they'd leave the company, and then you have this hole that with a knowledge gap around a very business critical piece of technology. So that's really why it why we launched it.
Now, how common is it that an enterprise gives you a call and either is willing to admit or embarrassed to admit that they really have no clue where their crypto is or how? Is that a pretty common sort of thing? And I'm wondering how many of them are embarrassed to admit it.
Well, sometimes they have to because something bad has happened, right? I think the other thing, you can use PKI to encrypt things, right? So encrypt data at rest, right? If you do that, you need keys archived and stored very carefully so that you don't lose data. We had a customer that had actually inadvertently done that to themselves. I obviously won't name who that was, but they had set up on their own an internal PKI for the purpose of encrypting laptops and desktops and that sort of thing, and then wound up outsourcing all of their IT, and in that path lost all of the expertise around where all the keys were stored, how the archival worked, and literally wound up with 70,000 laptops and desktops that they couldn't decrypt. And so that's maybe the most extreme example of that. But I think whether you're running your own PKI or whether we're doing it for you, the need to have a complete inventory of all the keys, which I think is what you're getting at with that as well, Ed, is super important. And so, you know, there's the certificates that you buy, there's the certificates that you issue from an internal PKI. The other thing that we're seeing is a growing set of products which include embedded CAs. So there's all these new things in the enterprise like HashiCorp Vault and VMware and a whole lot of other things. It's a rather large list of products that have embedded CAs that you can make use of. And a lot of times those get turned on by parts of the organization that are not the same parts that run the rest of the enterprise PKI or certificate components. And that can lead to challenges in terms of oversight, policy, compliance, and that sort of thing too.
Now, one thing I've heard you talk about that I think is very impressive is the idea of life cycle emphasis and life cycle management of certificates. Help me understand how that works and how that's different from the way people have done it in the past.
Well, certificates are very similar to a driver's license. They're actually very much a digital parallel to a driver's license or a passport. And in both of those cases, one of the similarities there is that there is a predefined date of obsolescence, and that is, in the case of a passport or a driver's license, that's for a variety of reasons. Perhaps your address has changed. Perhaps you've aged and you don't look like the picture on your driver's license anymore, although maybe no one really wants to look like the picture on their driver's license. But there is this predefined date, and so that leads to having to have a plan for how those things get updated. Clearly, with a driver's license, it's well established. You do need to look at the date on your driver's license and update that. With certificates, you really want to look at it holistically from the point of how do I issue the certificates? How do I get them where they need to go? That tends to be something that everyone focuses on. In some cases, that's where it stops, and of course, that's where the problems may lie. But there are other lifecycle events in a certificate. If you're doing things like encryption and key archival, you need to have a plan and a policy for who's allowed to recover those archive keys. When can they be used? Who's allowed to get them? What logging and policies do I have around that? Same thing with revocation. Who's allowed to revoke that certificate and have it cease to be trusted? And then, of course, when the certificate starts to approach expiration, you need to know who's going to be responsible for updating that certificate. And clearly, there are products such as Keyfactor that can help with all of those parts of the life cycle. But certainly automation is the piece that of renewal is the piece that can help avoid downtime and that sort of thing.
In listening to these life cycle activities, particularly the automation, I think how important it is to devices and IoT, right? It's one thing for humans, but with machines, this is the means, this is the foundation for identification, authentication. Tell me, it would seem to me that's a massive growth area for public key infrastructure in the next 10 years.
It is, and as you mentioned right at the beginning, PKI has been around a long time, but what's happened lately is just this explosion of use cases, both in the enterprise and certainly in IoT. What we're seeing in IoT, it's in a lot of cases it's very new, right? But this concept of things that have never had network stacks now being able to communicate. As soon as you have an ability to communicate, you need to be able to do things like authenticate. How do I know that what I'm talking to is legitimate? How do I know that the information that I'm sending is secure? How do I know that a firmware update that I'm pushing out is legitimate? If you're pushing a firmware update out to a pacemaker or an insulin pump or something like that, while it's in use with the patient, you better make sure those are authentic. And the FDA has guidelines around that sort of thing. But the thing that we're seeing in a lot of cases is the first entries as organizations start to IoTify their devices. There's a tendency among a lot of folks to look at, I'm going to put a key or a certificate, and it depends on the device, whether it's a symmetric key or an asymmetric key or an actual digital certificate. The same principle applies, though. They'll put a key on at manufacture time, and then that's the beginning and end of it. Is that, I've got the device, now it can authenticate, I'm good to go. The challenge with that is and enterprises have known this for a while. The reason why certs expire isn't just to make people's lives miserable. It's because the algorithms age, right? The keys age. They become insecure over time. And that is just, also true for IoT devices, right? The fact that it might be difficult to update a key on an IoT device doesn't absolve you from the fact that the crypto that it uses will become insecure in about 5 to 10 years. And we can predict that sort of thing because the algorithms that we were using 5 or 10 years ago are not secure now. And so if you are building an IoT device that isn't updatable, you can't update the roots of trust or the actual device certificate, you are essentially signing yourself up for a point where the device will not be secure, will not be able to authenticate securely. And that can be a problem both for the security of the device, but also for the back-end system, right? If you think about the very common paradigm where you have a certificate on a device, and that device then phones home and talks to the back-end enterprise system or so forth. If you can't update the crypto on the device, that means that you have to have your back-end system trust in secure certificates. So you're actually opening a hole into your back-end network. Even if the devices, depending on what the device is, maybe they're not that security sensitive. The challenge is that then can become an attack vector into the organization, right? The Home Depot was actually hacked by someone sitting in a parking lot pretending to be a piece of HVAC equipment. And from you get pretend to be an air conditioner, you get into the store Wi-Fi network. From the store Wi-Fi network, you get into the back end corporate systems. From the corporate systems, you get into the credit card systems, and that is how essentially the path that followed. So it is important to really look at the use of cryptography across a given system holistically, right, from the back end pieces to the devices, and make sure that all those things are updatable, right, or you can wind up with a lot of problems.
On this holistic sort of emphasis, I would imagine it must be a bit of a challenge, like as a vendor, because things like when you're dealing with code signing, that's a DevOps team. SSH is probably the network team or something, and a lot of the PKI would be the security team, and that must be a challenge. I mean, maybe it's good that there's so much pervasive use, but how do you guys approach that? How do you get build like a culture of lifecycle management for crypto?
Yeah, and a lot of it depends on the organization. I think there are organizations where there's a pretty good relationship between IT and IT security and other parts of the business. Certainly there are others where it's not. Where the developers and app teams and so forth, they're the ones working on the product side. They're the ones more connected to bringing revenue into the business. There certainly can be an us-them kind of relationship there, which is a challenge with organizations. So a lot of what we do is to try to make sure that we reach out to all of those parts of the business. But it is, I guess if you're in the audience and on either side of that divide, and there's an organization, that sort of culture in the organization, I would encourage you to try to reach across the fence and make connections. I think that there are things that the product side and operations side knows about this stuff that IT and IT security doesn't, and vice versa is certainly also very true. But I was at an IoT conference a couple of years ago. There was actually a birds of a feather session on how to work around your IT department, and which just gives an example of like that's the mindset of a lot of folks. And in my view, I think that's the wrong way to go about it, because you really share the information.
Hence shadow ID, right?
Exactly.
I also love that you managed to verb IoT into IoT. If I might steal that one from you, that's pretty. I don't know if it's good or sad, but that is a verb.
Yeah, someone else must have done that, but yeah, it was convenient at the time.
Hey, I probably should ask this right up front. Do you guys get a lot of customers come when just a cert expires and and nobody can believe how bad the consequences are? Something that simple.
Sure.
Is that like in the company they go, oh boy, 2/3 of our customers come when they've messed something up. Is that pretty common?
It depends. Certainly with the certificate and key management, especially certificates, that is one of the bigger drivers is a cert expiring, and maybe the conversation in an organization starts with, who should be fired, because this happened. And there actually have been resignations and so forth that have happened from that. There was a certificate expired in the state of California that actually impeded their ability to report COVID testing results a few months ago, and someone actually did wind up resigning because of that. But yeah, you're right. There's nothing like an outage or some sort of incident to unlock spending. And of course, that's true in terms of breaches as well as certificate expiration. I think in terms of PKI as a service, when you look at our ability to actually run PKI for customers and to do so in a way that is as identical as we can possibly get it to what you would get if you hired a PKI expert, kept them on staff to design, deploy, operate, and so forth. The driver for that isn't always about expiration. It often is a little more forward-looking. A lot of it is more a part of movement to cloud. So cloud computing and the cloud trend itself. Part of it is about where your servers are, right? The other part is about being able to focus your expertise on the things that are more core to your business, right? So that everyone, or almost everyone, has moved email out of their organization and are now using one of the cloud providers for that. That means you don't need to have a Microsoft Exchange expert on staff anymore, right? You can have. It doesn't mean you need to get rid of that person, because usually the folks that are talented and understand things like Exchange and PKI and so forth are certainly capable of doing other things that are more core to the business. And so that's where we've seen a lot of that trend. It's as much about focusing your expertise and your experts on things that are actually a part of your business, and let us focus on the things that are core to ours, which is public key infrastructure and key management.
Ted, I want to close with a question. I want to ask you a little bit about the future. And as you think about PKI and the work that you do, you're such an expert in this area. What do you see on the horizon? What sorts of things should we be looking for? We're filming this the end of 2020, so we're kind of on the cusp of 2021. What do you see coming?
Yeah, I think there's a number of aspects where I think you'll see more of the same. I think the trends such as that we seem to get a story about a certificate-related outage or breach about once a month hitting the news. I predict that will continue. That's not a very bold prediction, but it's certainly, and that's just an artifact of the explosion of certificates and the fact that a lot of systems are still, kind of looking at what we kind of consider phase one of PKI, of sort of SSL certificates and that side of machine identities. There's a huge and growing number of certificates that won't ever be found in an SSL scan that are securing web services and device connections and those sorts of things, and are leading to a lot of the outages and so forth, and some of the even the Equifax breach, but that was a couple of years ago, was a part of that. So I think a lot of that will continue. I think I will not predict that quantum computing becomes a reality in.
I was just going to ask you, right? I certainly not this year, but what do you think?
It won't be next year.
5 years?
I think and this is almost a religious debate, I think, among some as to whether or not it will even happen. But I think I'm of the opinion that it will eventually. It's probably more like 7 to 12 in my estimation.
Well, there's some quantum safe algorithms now that look like they may just obviate the need to worry about this, but
that's exactly. There's really two pieces there that can help, and both of those really should be something that folks pay attention to now. One of those, as you mentioned, is there are quantum safe algorithms. There are ways to actually start using quantum safe algorithms today, although it would be, there's standards that are close to being ratified. So, it's difficult to do something that will be a standard right now. But there are ways to use quantum safe algorithms today in systems where you just know you can't update something. The other thing, of course, is we talk about crypto agility all the time. The whether quantum becomes a reality or not, like I mentioned earlier, the algorithms and keys that we're using today will become insecure anyway, right? The algorithms and keys that we're using today will likely become insecure before quantum becomes a reality, right? So it won't be because of quantum, at least not these algorithms. It'll just be because, Moore's law and cryptographic advancements and mathematic achievements and so forth. The algorithms we were using, again, 5 or 10 years ago, we don't use today. They're obsolete. And so the same things that you would need to do to prepare for quantum, having a complete inventory of all your keys, certificates, not just the ones you find in an SSL scan, not just the ones that you bought from a certain vendor, but literally every single key and certificate needs to be in an inventory so you know what you have, so that you can start planning for how am I going to replace this when I need to, either because it's a cert that's expiring, or because it's a SSH key that's using an algorithm that's been compromised, or a symmetric key on an IoT device that has now been deemed insecure. You can't do any of that planning unless you have an inventory, and that's the first place to start, obviously.
Well, I'll tell you what, it's every time you and I chat, and I've had the pleasure to chat with you a number of times, I always learn something. I always go back and watch the video over because there's so many things that you're sharing. I want to make sure I'm absorbing. But for people watching, I would imagine the Keyfactor website may be the best place to get in touch with you. Is that the best way for them?
Absolutely, keyfactor.com. There's a lot of great information, a lot of resources there, blogs and so forth. There is, feel free to find me on LinkedIn and connect. I'd be happy to connect with anybody in the audience as well.
That's good. I'll look up there. And you tweeting cat pictures every couple hours or anything like that, or not?
I don't. I'm simply a viewer of cat pictures. I rarely tweet, but.
That's funny. Well, listen, Ted, I want to thank you so much for making time. On behalf of people watching and our whole team at Tag Cyber, I want to thank you for sharing.
My pleasure. Thanks a lot, Ed.
And for the rest of you, we'll see you next time.